Alright, hello everyone and welcome to the solution for O-Level Computer Science PRM May-June 2022 Paper 2-2. In this video, we'll be looking at what the question requires of us. We'll be understanding the tasks themselves, how we might go about setting them up, and how to get the tasks done in successive order. In the next videos, we'll be looking at the pseudocode of the tasks themselves. So this is just an overview. This is for us to build an understanding of what the question requires of us and to sort of realize how we might go about solving it. And in the next two videos, the next one being for task 1 and the one after that being for task 2 and 3, we'll be looking at the pseudocode solution for each of those tasks. So let's get right into it. This is the examination question for PRM paper 2-2. And it says that you need to program that a program is needed to allow a wildlife park to sell tickets. A booking consists of one or more tickets for the same days, and it can be made up to a week in advance. A booking can be made for a visit of 1 or 2 consecutive days. So here's just something to keep in mind. So when you're looking at questions like this, what the best practice is that you should sort of start building an intuition in your mind. You should start seeing what are some of the choices you might have to make, what are some of the branches that your code might have, right? So we have two things in mind. We have 1 day and we have 2 days. So this might be something that becomes useful to us later in the code. Just keeping in mind that we have 2 options for the days. Then it says that a booking can have extra attractions included, and a booking will be valid for the days chosen. So we have some pieces of information. We know that our app, our code is supposed to be something that something for purchasing tickets, right? So it will have some element of inputting the number of tickets you want. It will have some element of choosing which option you want, right? So and that becomes clear when you look at this part, that this has all the different values, right? It has the ticket types, and then it has the costs. So one thing that can immediately come to our mind is that somewhere in this code, one of the things we'll have to do is to select which of the versions, which of these options we want to choose, right? So like I said, building an intuition for the question is a really good practice, and one you should keep in mind whenever you go about solving any question. So here we have all the ticket types. We have 1 adult, we have 1 child, we have 1 senior, we have a family ticket, and we have groups of 6 people or more. So each of these come with their own prices, and each of the prices are in 2 categories. There are prices for 1 day and there are prices for 2 days. 1 day, as you can see, for every single one of them, it costs less than the price for 2 days. However, the cost is not directly a multiple of 2. So the cost for a 1 day ticket is $20, but you would assume that a cost for 2 day tickets would be $40, but it's not. It's a discounted price, sort of how bundle packages work in the real world. That it comes at a discount, right? When you're buying it when you're buying it together. So the prices are in their 2 separate categories, one for 1 day and one for 2 days. Now one of the things that we should do is sort of start to visualize how we might represent this information in our code, because a computer algorithm is all about handling information, right? It's all about handling and processing and manipulating information. So when it comes to this information, how might we go about storing that? So one of the things that can come to mind is that we have this structure. If you're familiar, this might resemble something we've done, which is an array, right? This might represent this might look familiar to you, and it might remind you of an array structure. So what we can do is we can store all of this data in an array. So we can store 1 array for the prices for 1 day. And each of these elements would correspond to each of the prices. Now, one thing we should keep in mind here is that whenever we're talking about the indexes will specifically be true, or rather they will specifically correspond to a certain ticket type. For instance, If I declare another array of a similar structure and I say that this one represents, just bear with me for a second, this one represents the prices for 2 days, the first index of this array will correspond to the same type of ticket as the first index of this array. So if this is $20 and this is $30, then these both represent the ticket type of one adult, right? So the first index refers to the first ticket type. Similarly, the second index will always refer to the second ticket type. So this would be a child. So this would be populated as such, right? 12.00 and 18.00. And again, like these arrays would have the data type real, and the reason they would have this is the fact that we have added the decimal and the 0.00, right? If it was integer, it would only be 18 or 30 or so forth and so on. It wouldn't have the decimal points, but since we are adding decimal points, we do need the real data type, since the real data type is the type that stores the decimal points. Now you might be asking, why do we need the decimal points when we're clearly just writing 00, and 12.00 is the same thing as 12, right? So why are we storing it as a real and not as an integer? And the reason is quite simple. One of these values, or well, some of these values, so this one and this one, is not a 0.00. This is a 0.5, so it's 2.5. And if we try to store this as an integer, it would just get rid of the entire decimal, so that would become 2, and 2.5 is not equals to 2. So there has been a little mishandling of information here. This would make our code go wrong. It would incur a logic error, since the code is not doing what we want it to do, because instead of calculating the price for this attraction as 2.5, or let's say this ticket as 22.5, it would then be calculating that as 22, and that's not accurate to what we want it to do, right? So that is why we are choosing the data types for this array as real. So similarly, the third index would represent the senior ticket, so that would be 16.00, and for this it will be 24.00, and you get the idea. So forth and so on until the entire array is populated. And this is the last one of this. Apologies if you can't see the decimal, it's just really tiny. So there's 90.00 here, and then there's a 22.50 here, right? So this is how you might store the data for the prices. Now, one thing that we need to consider in advance is that we also need to store the types of tickets, right? And why we need to store them will become apparent as we go further into the question. But I want you to think about how we might store the data, the actual ticket names, and how we might store them implementing an array. And let's move on with the question, and we'll come back to this when we reach that part. I just want you to like start thinking about that right now, and we will come back to this in like 2 minutes. All right. So this is the data for the tickets. Then in a similar manner, we have one for extra attractions. So this is a separate type of ticket that the visitors can buy, and these come in 3 variety. So they come in the lion feeding, the penguin feeding, and the evening barbecue. So once again, we could declare an array of, let's say, data type real. And again, it's real because of this entry, the 2.5, because the 0.5 we need to store that as an actual number, right? We can't just get rid of that. So that's why we are storing this as a real. And here we have 2.00 and 5.00, and this could be, let's say, the extra prices, right? So this is for extra, this is for 1 day and 2 day. I'm going to leave you on a similar question, and which we'll come back to in just a minute, that if I wanted to store the data for this, so if I wanted to store these, how might I go about doing that using an array implementation? Alright, so next what it says is that we must write and test a program or programs for the wildlife park. So for this entire setup, and what our program or programs must do is that it must include appropriate prompts for the entry of data. So what a prompt is it is just some output that is given to you on the screen before you have to input the data. So and I'll show you what that means when we do the actual code, and when I show you what the finished code would look like. So we're gonna run that instance at the end of the video, and the prompt is basically just the output text before you enter the data. So if it says enter your name, and then there's a space for you to enter the name, enter your name, that is the prompt. And then it says that data must be validated on entry. All outputs, including error messages, need to be set out clearly and understandably. So essentially what it means is that anything we're outputting at any time, even if it's an error message, so and an error message arises because of our for our validation. So data must be validated on entry, and if it's not validated, if this turns out to be false, then from here we will then why is it not drawing? Then from here we will say that okay, the data is not validated. That means that it must it must be an error, and so it will then set out the error message. Then it says that we have to accomplish the three tasks, and each task must be fully tested. So task 1 is to simply display the ticket options and the extra attractions available. So we have to set up the program to display the options, attractions, and prices for 1-day tickets. We have to display the options, attractions, and prices for 2-day tickets, and we have to show the number of days available for booking, the days available rather, and assume that any valid day, so any valid day has the availability of a ticket. So let's say that so basically assume that there are tickets available for any valid day. Now a valid day is just a day that exists, right? So Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, or Sunday, those are all instances of valid days, right? Now, when we start to implement this, see how it says that we have to display the options, attractions, and prices. So attractions, we will display just as cost per person. So we'll display that as a separate block of its own. But when we have to display the tickets, note that it says the options and the prices. So these are the options, the actual text of what we are paying for. So if we're paying $20, what are we paying for, right? We are paying for one adult ticket. So the one adult category of the ticket, that is the option. The text of the text of the purchase, that is what we are calling the option. And so this ties in to the question I asked earlier, that if we wanted to save this data, how might we do that in an array? And the answer is that we declare an array which is of type string. And I'm sure many of you must have gotten to that on your own, but here's how you would do that. So you have another array, and don't worry if you didn't, like it's completely fine. It wasn't meant to be it was just a question to get your minds working. It wasn't meant to be a very obvious answer. So here we have a array declared as string, and we can just call this, let's say, ticket types or anything like that. So let's just say tickets. This is an array tickets of type string, and basically what it would include is the first index, which again, remember that in our arrays the indexes all correspond to the same thing. So when we're talking about the tickets, the first index of the 1-day tickets would be referring to one adult. Similarly, the first index of 2-day tickets would be referring to one adult. And here in the tickets itself, the first index will contain the name of the ticket. So one adult is what this would store, since that is the text of this ticket option, right? So then we have the second index, which would contain one child. I'm not writing all of those down, but you get the point, right? So this would contain one child, and this would contain a senior, and this would be a family ticket and a group ticket, and so forth and so on, until this is our entire population of arrays. In fact, you know what, let me just go ahead and write that real quick. Alright, so here is what our entire array set would look like. Now this array set is all we need to implement this table. So this entire table, this is implemented with these sets of arrays. So these three arrays together, they represent all the data of this table. Now if you might have noticed, this is sort of similar to just taking this table and breaking it up into its columns, right? So this column, the tickets column, becomes one array, the cost for 1 day column becomes an array, and the cost for 2 day column becomes an array, right? So these are exactly what we have stored. So this is this one, this is this one, and this is this one. This is getting incredibly messy, so I'm just gonna remove all of this, but just so you get the idea. So this is what we did, right? Here, let's just get rid of all of this. Okay, so that was the implementation for that table. Now the way we're going to implement this table is in a similar manner. So we have the prices, which is in an array of, let's say, extra and per actually let's call this extra cost for now, and I'll show you why in a second. So let's say that this is our array extra cost, and this is the data, and the data type is real, and it has all the values stored, right? So now in a similar manner, let's declare an array of type string, and let's just call this extra, just for the sake of the name. And here we have the actual names of what it would correspond to. So 1 2 3, 1 second, that is horribly written. Let me do this again. Here, 1 2 3 and 1 2 3. So this is lion feeding, this would be penguin feeding, and so forth and so on, right? So this would be the second one, and this would be the third one. And again, like the indexes, the third index corresponds to the third item, so this price corresponds to this this entry, right? So this is the implementation for the second table present in our data set. So these two arrays make up this table, right? So this is again similar to just taking the table, breaking it up into two columns, and each column becomes its own array, right? An array. So that is the implementation of that. So now what we need to do, what the task actually requires, is that we have to display all the options for 1 day tickets, 2 day tickets, and we have to show the number of days available, right? So what we would essentially do is that let's say that we have 1 second. Let's say that this is our screen. So this is our screen, and here we have to display all the options, right? So what we could do is, first we could display all the ticket options for 1 day tickets, then we could display the ticket options for 2 day tickets, and then we could also display the options for the extra attractions, right? And as soon as a person tries to purchase one of these, we would show them the number of days available, or we could even do this before or after or somewhere around here. So like either at the start of the code, we could show them that, okay, these are the number of days available, or we could do it at the end of the code. So after we've shown them the extra prices, right before they start to purchase, we can show them that this is these are the days you can choose from, right? So let's say we have this can be the number of days available, and then this is our entire screen. So this is what it would look like. This is the block for 1 days, for 2 days, for extras, and for the days, right? So this is how we could implement task 1. So task 1 says display the options, attractions, and prices for 1 day tickets, display it for 2 day tickets, and display the number of days available. So we've done that. We have shown the 1 day tickets here, we have shown the 2 day tickets here, extra attractions, which are common in both of these. So this part, the extra attractions part, we've done that. And then we have days, which we have done here, right? So this fulfills all that we need to do for task 1. Now, what is task 2? So if we take a look at this here, it says that task 2 is the task of processing a booking. What now? It's the task of processing a booking, right? So for this task, what we have to do is we have to extend our program from task 1. So basically this continues over from what we've already written, And what it does is that it inputs the tickets and the extra attractions required, and then it calculates the total cost of the booking. So essentially what we're doing is we are selecting, one second, let me zoom into this properly. What we're doing is that we are selecting one of these options. So let's say, let's scroll here a bit and then here. So whatever we choose from here, so let's say I want to purchase the 1-day ticket for a child, right? So the 1-day ticket would be this array, and then a child is at the second index, right? It's at the second index, which means that in the price in the price array, it would the price for the 1-day of the 1-day ticket of a child would also be present at the second index. So this index, this is the corresponding price for that ticket. So I just fetch this data, I get this, and what I do is I add it to some variable that I have, which would be total price, right? And again, you don't have to completely understand the code of it, because we're not really getting into the code of it. We're just sort of building an understanding of what we're going to have to do to solve this question, right? But if you can't see how the code would be just yet, it's completely fine. You're not supposed to. You're just supposed to understand what the task requires of us. You're not really this video is not about the programming itself, right? So just sort of understand the structure, understand how we're going about it, but you don't really have to worry about the programming aspect of it right now. So we notice it says tickets and not ticket, and extra attractions and not, attraction. That means that the total price is going to be updated over and over again, as long as we have another ticket to input. So there could be multiple tickets input from all different categories. So we could have multiple adult tickets, we could have multiple senior tickets, child, all of them, so forth and so on, right? You get the point. And similarly, for the extra attractions, we could input them however many times we want until the user decides that, all right, enough is enough, I am done purchasing tickets, and then we stop updating them, right? We stop adding more of them. So let's see if I can't get rid of this. Never mind. Task, yeah, so that is the beginning of task 2. Yeah, I'm not gonna bother. Okay, then we have to allocate a unique booking number, right? And what that basically means is that every time, so let's say that this is the code for our let's say that here this entire part represents let's just say that for now this part represents us purchasing the tickets, right? So this is the purchasing part. All of the code for purchasing a ticket lies within this part. So this is the purchasing. This is where our buying happens, right? So what this means is that every time we purchase a ticket, we're going to have to increment some, let's say, ID, right? Booking ID, booking number, whatever. Like we're gonna have to increment the ID. So it would be ID equals ID plus 1, and initially we could have the ID of, let's say, 1, right? We could instantiate it as 1. We could initialize it as 1. And so the sort of insight that this gives us is that if there's going to be a counter, basically every time we increment this, it's acting as a counter, right? It's counting the number of times we have run a specific program, because the number of times that the tickets have been purchased, that is the ticket number, right? So a ticket number 5 would mean that this is the 5th ticket purchased in the day, and so this ID, this variable is acting as a counter, and we know that whenever there's a counter, there is usually also a loop. So from this, we can sort of infer that this purchase algorithm would be running in its own sort of loop. So this would be looped until we wanted it to exit, right? So if we wanted to exit, we could say that, okay, so this is a loop, but instead for some value, it comes out. So instead of going back into the loop, it comes out of the loop for some value. And that value could be the user saying that they don't want to enter any more tickets, or the day is over, or something like that. We don't really know, because that's not a part of the code yet, so we don't need to know that. But just conceptually, this is what would be occurring. So it would be running in this loop until it decides that it doesn't want to run in the loop, and it exits the loop, right? That is essentially how the purchase part of task 2 is going to work. And that is how we assign the unique booking ID. And yeah, so let's just say that in here, every time that the code is running, we have the ID being incremented. So we have ID equals ID plus 1. That is happening for every time the loop runs, right? So next what we're supposed to do is we have so next what we have to do is we have to implement the display booking details, right? So what we have to do is that we have to display all the bookings that have so far been made, or rather every time a booking is made we have to display the booking details, and that includes the total costs and the unique booking numbers and everything that has so far been calculated, right? So we calculated the total cost of it, we calculated the like this entire part. So we calculated what the booking ID is right here, and we calculated the total price right here. And so each of this has to be displayed within within the task, right? Now, an important point to note is that every time a ticket, a booking is made, that is when we are going to be actually showing the details, right? So a booking is made within this loop. So the display part will actually be occurring within the loop itself. So this part of the code, which is just like displaying everything. So let's just call it display. This is something that's going to be running inside of the loop. Once we come out of the loop, here the program ends, right? This is where everything ends, because now we are no longer making another purchase. We don't want to do that anymore, and the day is over essentially. So like the only way that we could exit is when the day is over. So there is no more tickets because the park is closing down, and that means that there is nothing more to be done, right? And that is when we're going to be exiting. So that is the only way that we exit the code. Everything else that happens, that happens for purchasing tickets, that happens within the actual loop of the tickets being purchased, right? I hope that makes sense. And so what we have to do is we have to display that, and so with the total cost and the unique booking number and all of that, right? So lastly, we have task 3, which is ensuring that each booking is the best value. Now this is where it gets interesting. So like just follow along. So what we have to do is we have to check that the total for each booking gives the best value and offer so it gives the best value and offer an alternative if it's not the case. So essentially what we're doing is that we are looking at all the tickets that that our user has purchased, and depending on whether those tickets are the best combination of prices for like the price of those tickets gives us the best price or the lowest price as compared to any combination of these tickets that you can do. If it is the best price, then we say that okay, you can move on forward, and if it's not, then it would offer us the alternative. It would tell us that the best option is whatever, and then like whatever the best option is, right? So how might we go about doing that? Like, how do we recognize whether or not the person has chosen the best value for their tickets, right? So one way of doing that is to realize that this exists because this is for a group of 6 people, this price is the lowest price per person that it can get. So when it comes to all of these prices, the senior price is more than the 15 and the adult price is more than the 15, right? The only exception is the child cost, which is less than how much a child ticket would cost per person. However, a child cannot come without an adult, right? So if there's a child present, there has to be an adult present. I don't know why I wrote a 1 there. This is a C. If there's a child present, then there's an adult present. And if the child ticket is being purchased, so that is a decrease in value. So that's less efficient by $3, right? We're paying $3 extra for the child. However, the adult ticket is also purchased under the same category, right? So this is price per person. So now suddenly the adult price is also 15, and so this is actually a profit for us of $5. So the net effect is that we are saving $2. So whenever we have six or more people, the best solution is to buy this ticket, because as we just saw, once we eliminated the fact that the only possibility where we were losing money, that is also under the logic of this program, that is also not actually a loss, it's a profit of $2. That means that this ticket is the best value for any group of people consisting of six or more individuals. However, at the same time, we also have this option, which is an option of a family ticket. Now, what might this what benefit might this bring us? Well, let's have a look. So it says that up to two adults or seniors and and three children. Those are the compositions of the family ticket, right? So what this means, up to two adults or seniors. So what this means is that the combined number of adults and seniors, so it needs to be two, right? So this could basically mean that there's two adults and zero seniors. It could mean that there's one adult and one senior, or it could mean there's zero adults and two seniors, right? Ignore this line. So this is the total number of combinations that can exist for this part, right? So that's what this means, up to two adults or seniors. Also, this is the maximum amount required, right? It says up to two adults or seniors, so it doesn't have to be two, it can be less than that, but as long as the combined numbers of adults and seniors are two or less than two, then this family ticket holds. And then we say that it's that and it's three children, so it is two adults or seniors and it is three children, right? So now also what you should note is that a child, like one adult can bring up to two children. So if there are three children, then that means that there's automatically more than one adult slash senior, right? So the up to part here, because of this constraint, the up to part isn't really useful here, and we automatically just know that there are going to be two adult or seniors, right? Because without that we can't have three children, because one adult can bring up to two children, and since there's three, that means there's more than one adult here, which means that there are two adults, right? So this family ticket applies for when we are purchasing a total of two of these and three of these, right? So that is what this means. Now this cost, and you can do the math behind this, this ticket is the most efficient ticket, or the most cost effective, so it's the best value ticket for any instance of this of a multiple of this. So what that means essentially, and they've given a really good example of this, by the way. So they're saying that, for example, buying two family tickets is better than a group ticket for a group of 10 that includes 4 adults and 6 children. Now I want you to remember that it says 4 adults and 6 children, right? Now is there a pattern that you can sort of see between this and this? Is there something in common? And if you did catch that, then you probably would have caught the fact that this example is a multiple of this. So we have so 4 is a direct multiple of 2. A multiple, I don't know why I said direct multiple. It's a multiple of 2, right? So 4 is a multiple of 2, and 6 is a multiple of 3, and the multiple in this case is 2. So that's important, that the multiple has to be the same value. It can't be like let's say 6 adults and 6 children, because that is not a valid multiple, right? If we want 6 adults, then we're multiplying this by 3, which means that we also have to multiply this by 3, so that would be 9 children, right? So as long as the multiple is the same and our values line up such that they are multiples, this ticket would be the best option for that group, right? And just know that this makes up a group of 10 people, right? And so if we were trying to purchase this group of 6 people or more, price per person, then this cost would come out to be $120, right? Sorry, $150. So this would be $150. However, if we're purchasing 2 family tickets, the cost comes out to be $120. And I mean, I don't need to tell you that that is a price saved, that is money saved of $30. Right. So clearly, the family ticket is much more efficient whenever there's this situation that the group in question consists of multiples of this expression, right? So the number of adults has to be a multiple of 2, and whatever that multiple is, the number of children have to be the same multiple of 3 for that value. Now I know that was a lot. There was there was mathematics in there which you might not have expected there to be. I know that was a bit of a tricky thing to maybe wrap your mind around, but when we start coding this, when we start looking into the algorithm for this, it'll make a lot more sense. Right now, just know that what we're going to be evaluating, what we're going to be finding out is whether the group is of this form, so a multiple of this form. If it is this form, then the best option is the family ticket. If it's not this form, then so like basically if and else if, right? So if this, then the family ticket is the best option, or like family tickets is the best option. If not, so like we're now in the else if, right? So else if the number of people is 6 or more, so the number of people in the group is 6 or more, then automatically this is the next best value, right? So the next best is this. So either it follows this format, in which case the family ticket is the best option. If it doesn't, then we have to check whether it is a group of 6 people or more, and if it is, then this ticket is the best option. And if both of these conditions fail, so basically the else statement, if both of these conditions fail, then the individual tickets are the best options, right? So these are the 3 constraints, or really the 2 constraints and the 1 else condition that we have to keep in mind when we are seeing which booking is the best value. So that is the concept of what we're going to be doing in this entire PRM. And so in the next video, we will look into the pseudocode for task 1. Also, when we look into the pseudocodes for task 2 and 3, I'm going to merge them because the code for task 3 is actually a code that exists within the code for task 2. So when you're actually writing the code, it is much for this algorithm, it's much more efficient if the code for task 3 sits inside the code for task 2, right? So so task 2 and 3 we'll be looking at together in the same video, and task 1 we'll be looking at in a separate video. So the next one is going to be the video for task 1. All right, so thank you for watching, and I will see you in the next one when we discuss task 1.